Hello, this is Danny from Geocene, and in this tutorial you will learn how to analyze data using Geocene. You can add raw data to your Geocene account by syncing data from Geocene devices using the Geocene mobile app, or, as discussed in a previous video, you can import data from other manufacturers' meters using the import tool. After you have added raw data to your Geocene account, you will probably be interested in analyzing that data. The main tool for analyzing your data in Geocene is called a processor. A processor allows you to analyze all or just a portion of your data using custom analytics models. Geocene's analytics system is centered on the idea of looking for interesting events in your time series data. For example, you can use Geocene's analytics to find the highs, lows, spikes, wiggles, or plateaus you care about in your data. In this training, we'll discuss the specific use case of detecting cooking events from temperature data recorded from different types of cook stoves. In a previous video, we imported and tagged a set of temperature data logger files. Now, we can process our temperature data into cooking events using a processor. The first step in creating a processor is to filter down your missions to the set of data you want to process. In the case of looking for cooking events from temperature data, I know I'm going to need to process data from different cook stoves in different ways. For example, the temperature data collected from a three-stone fire has different characteristics than the data collected from a rocket stove. A three-stone fire has higher thermal mass, so it will heat up and cool down more slowly than a rocket stove. But even though it heats and cools more slowly, the probe might be placed in a location where the peak temperature is higher than the peak temperature measured from a rocket stove. It would be difficult to use the exact same algorithm to determine cooking events from these two different types of cook stoves. Therefore, for the first processor, I'm just going to filter down to my three-stone fires. After filtering down to three-stone fires, I can see that this processor will apply to 5 missions. In the future, if another mission tagged three-stone fire is added to my account, this processor will automatically process these data. Next, you will choose an analytics model to process your data. A model is an event detection algorithm that can detect events from time series data. Currently, Geocene offers 3 options. The threshold model simply finds events by looking for data above or below a certain threshold. The constant model looks for long runs of unchanging or constant data. And Firefinder is a specialized algorithm that is good at detecting heat addition events in temperature time series data. Let's choose the Firefinder model to detect our cooking events. After choosing your model, you will be prompted to parameterize and customize your model. Firefinder allows you to pick 4 different parameters: minimum event length, maximum gap between events, minimum intra-event value, and most importantly, primary threshold value. The minimum event length is the minimum duration in seconds that an event must last to be considered a real event. Events shorter than the minimum event length will be discarded. Minimum gap length is the minimum gap length between 2 events to consider the events to be distinct events. For example, 1 hour of cooking followed by a 1-minute gap, then another hour of cooking is probably not 2 separate cooking events. It's actually probably a single 2-hour cooking event. If the gap between events is less than the minimum event gap you specify, the 2 events will be merged into one. Next, the minimum intra-event value is the minimum temperature or value for a cooking event to be considered a real cooking event. For example, Firefinder's logic may label a rapid rise in temperature as cooking, but that rapid rise may top out at just 40 Celsius. You can use the minimum intra-event temperature to drop entire events who never exceed a particular peak temperature within the event. Finally, the most important parameter in Firefinder is the primary threshold. Firefinder is a relatively complex algorithm. It's not just a simple thresholding algorithm, but the primary threshold is a parameter you can use to increase or decrease the sensitivity of Firefinder. Think of the primary threshold as the level above which you would consider an event to be unambiguously happening. We recommend that you choose a primary threshold that is safely above the peak ambient temperature and above any temperature rises that could be attributed to things like sunshine or waste heat from nearby stoves. For example, If you are looking at temperature data from India in the summer, where ambient temperatures can regularly reach 45 degrees Celsius, a primary threshold of 65 Celsius or so might be appropriate. In summary, model parameters allow you to customize your model to analyze your data your way. The last step in designing your processor is to name the processor and the events that it will find. The names that you give your processor and its events will have no impact on the performance of the processor. However, give your processor and its events descriptive names. This will help you analyze and understand your data in the future. After completing your processor, your data will begin processing. Depending on how many missions you have selected and the complexity of your model, your data should be finished processing in about 5 minutes to an hour. After your processor completes its first run, it will run at least once per day, every day. If your original missions gather new data, or if your tag and campaign filter set results in new missions, those new data and/or new missions will be processed by your processor. After your processor has completed at least one run, you can use the study module to explore detected events. The study module allows you to dynamically filter events from one or all of your processors. Filters in the study module allow you to look at events by mission, processor, event name, tag, or campaign. Below the Filters menu, you will find useful tables and charts that summarize your events. The first table summarizes all your filtered events by processor. This is useful for determining overall aggregate behavior. Next, the second table summarizes filtered events by mission and processor. This will allow you to look at total events on a mission-by-mission basis. Next is a table that lists every event one by one, and this can be a useful tool when you're looking at especially long or short events, or events that occurred at a particular moment in time. To evaluate the performance of your processor, it can be useful to click on the missions with significantly more or fewer events than others, or to explore especially long or short events, which may be suspicious. Exploring the output of your processor in this iterative way may give you insights about how to refine the parameters of your model. You can go back and edit your processors at any time. At the bottom of the study page, you will find two charts which plot total events and event duration versus time for all of your filtered events. These charts are stacked by event kind, so you can explore multiple kinds of events at the same time. In this example, both cooking and excessive temperature events are stacked, so I can see the historical occurrences of stove use and the occurrences of possible sensor damage in one view. If you would like to explore the results of your processors using a different analysis tool like R, Python, or Excel, you can export the results of your processors using the Export Data feature. Thanks for watching this Geocene tutorial. We hope Geocene's powerful analytics tools are helpful for your next data analysis project.